Last video for this chapter, we're going to talk about a few other types of concentration units that aren't quite as commonly used in chemistry, but are still fairly common, especially in other fields of study. We're going to start off here with mass percentage, parts per million, and parts per billion. Now you might notice this mass percentage is exactly the same as the percent composition we talked about earlier. It is literally exactly the same. Sometimes people will refer to them as different things. You might even remember in a few videos ago when we were talking about percent composition, I kept referring to it as percent mass because they are literally the exact same thing. It's just now we're referencing a solution instead of referencing a molecule. But the actual calculation, the equation, is exactly the same. So the mass percent of a component in a solution is just the mass of the thing that you're interested in divided by the mass of the entire solution times 100%. So again, exactly the same thing we saw before, only before it was specifically in reference to a molecule, and now we're just applying it to a solution. But the actual stuff we're talking about, the calculation itself, is exactly the same. So that is mass percent. Parts per million and parts per billion are very, very, very similar. They're used most often for very low solute concentrations, just because it's easier to say 10 parts per million. It's easier to say that than 0.00001% mass. Like it's easier to use parts per million and parts per billion. Those two units of concentration, again, are exactly the same as mass percent, except at the end, instead of multiplying by 100 for parts per million, you would multiply by a million, and for parts per billion, you would multiply by a billion. But other than that, all the rest of this here is exactly the same, other than obviously specifying that this is parts per million and parts per billion. But it's just the name of the unit is equal to the mass of the thing you're interested in divided by the mass of everything. That is exactly the same. And then you just multiply by a larger number. And so this just, in effect, takes numbers that would have been very, very tiny and makes them more manageable. Because it's usually easier to talk about 10 parts per billion instead of, 1/1000th of a mass percent. Like it's easier to conceptualize that for most people. Another unit that is fairly often used is volume percentage. This is especially useful in medical settings, which is the same for the next one as well, the mass to volume percentage. So volume percentages, exactly the same as mass percentage, just with volumes instead of masses. So the volume percent of a component is the volume of the component in the solution divided by the total volume of the solution times 100%. And the mass volume percentage is usually going to be the grams of solute per 100 mils of solution. But that can vary a little bit just depending on what you're looking at. Sometimes it might be out of a liter instead of out of 100 mils, or some other slight variation like that, depending on where you're getting stuff from. Maybe they might even use English units, which would be just a nightmare. But usually it is going to be the number of grams per 100 mils. Like I said, it's usually used for medical settings, that mass volume percentage. So let's do one quick example here, and then we will call it a day. So this question says rubbing alcohol is usually sold as 40% by volume aqueous solution. If the density of isopropyl alcohol is 0.785 grams per mil, how many grams of isopropyl alcohol are present in a 355 ml bottle of rubbing alcohol? Okay, so this one is a little bit tougher than the ones we've seen before, but I would still like you to go ahead and pause the video and see if you can work this out on your own. The biggest helpful hint, I guess, that I can give you is to think about these equations. Like, think about the equation itself and what you know, and then extend your knowledge beyond just the equation as well. Think about other things that we've talked about before. So go ahead and pause the video, see if you can work this out on your own, and if you're thinking, I'm just going to wait and see, watch him do it, think about how good you'll feel if you can work this out on your own. And even if you can't work it out on your own, I already told you it's kind of tough, and so you have no reason to feel bad about not getting it right. So there's only an upside here. So go ahead and pause the video and see if you can work this out on your own. Alright, I hope you paused and tried to figure this out. One of the first things that we really need to do here is we need to really nail down and specify what are we actually trying to find. So, we read the question carefully. It says, how many grams of isopropyl alcohol are there in this volume of rubbing alcohol? So, we are trying to find mass. Trying to find the number of grams of the alcohol that are in a volume of solution. Because the rubbing alcohol is not just isopropyl alcohol. Rubbing alcohol is only 70% rubbing alcohol. So we want to know what is the mass of the isopropyl alcohol in the whole solution. So let's think about what we're given here. We're told that rubbing alcohol is 70% by volume. What that means is 70% of the solution is the isopropyl alcohol. The other 30% would be water. So if we think about that in terms of our equation back here, we have 70% isopropyl. I'm just going to say 70% iso, just so I don't have to write the whole thing every time. And we're told that we have 355 mils of everything. The total volume of the solution goes down here. So then the volume of just the thing that we're looking for would be this part here. This would be the volume of isopropyl alcohol. Then we have it times 100%. Oops, ran out of space there. Times 100%. So, if we can solve this to get the volume of the isopropyl alcohol, then we can use the density to convert volume into mass. Because remember, density is the mass divided by the volume. Density is essentially a conversion factor between mass and volume. So if we go ahead and solve this, so we're going to divide both sides by 100%, so the percentages are going to go away. So 70 divided by 100 just gives us 0.7, and then we're going to multiply both sides by 355. So that'll get rid of the 355 down here, so it'll be 0.7 times 355. That tells me that my volume of isopropyl alcohol is 248.5 mils. Because it has to be the same unit here. Because that unit didn't go away. It didn't get canceled out. So we have 248.5 mils. I know that the density of isopropyl alcohol is 0.785 grams per mil. I don't know what mass I have, but I do know that I have 248.5 mils. And so if I do a little bit of algebra once again, multiply both sides by 248.5, that's going to make my mils cancel out, leaving me with grams. And I will finish with, let's see, 0.785 times 248.5, 190 let's see, I only get 3 sig figs. So 195 grams of isopropyl alcohol. All right. If you paused the video and tried to work that out on your own, I hope that you came up with that answer. Excuse me. And if not, I hope that you at least were able to work out a few of the parts there. That is the end of Chapter 3. So please do remember to go and start up with the homework. Hopefully you've already started it at this point, but be sure that you're working on the homework and getting that done in time. If you have any questions over this stuff, feel free to email me or to ask at the next Collaborate session. And I will see you all next time.